This lesson is going to pull everything together over the last couple days. We're going to combine some of those new double angle formulas, those double angle identities for sine and cosine, along with some trig identities and some trig equations. This is like the capstone of our work with trigonometry. So if we take a look at this first one, we want to prove that the left side of this equation equals the right side. We've done the identities before, so just remember some of the rules. Rule number one is only work on one side of it, converting that side to equal the other side. Rule number two is when you're done, put like QED, or left-hand side equals right-hand side, something to just finalize your answer. So I'm looking at this, and I think there's a lot more stuff going on the left-hand side. So I'm going to start on the left side. So I know the sine of 2x. I remember that identity for the sine of 2x is 2 times the sine of x times the cosine of x. And that's pretty good because I see a lot of other things on the bottom. I see my 2, I got sines, and that's all good stuff. So I'm going to write this, and maybe it helps if you see it this way. That sine squared x, as we say it, is really the sine of x times the sine of x. So I just write two of them together. Now, what we'll notice is that when we cancel some things out, the 2's cancel. One of the sines on bottom cancels with the sine on top. And I'm just left with cosine x over sine x. And we know from our previous work that cos x over sine x is equal to cotangent x. So we've shown the left side equals the right side. That makes us happy. Maybe you want to try this one on your own. You can pause the video for a minute, give it a shot, come back later. Okay, welcome back. So again, I see there's a lot of stuff going on the left-hand side of the equation. Now I'm going to think ahead a little bit. Peeking at the right-hand side, I see it's tangent squared x. I know tangent is sine over cosine. So my logic is, if I use my double angle formulas for cosine and for sine, if I represent cos 2x in terms of sine and cos 2x in terms of cosine, I might be able to get like a sine over cosine situation. So what I'm going to do is I'm going to rewrite the numerator as 1 minus, instead of cosine of 2x, I'm going to use my identity 1 minus 2 sine squared x. And on bottom, instead of using cos 2x, I'm going to use the cosine formula, which is 2 cos squared x minus 1. Now let's do some distributing. If I do the distributive property in the numerator, I get a negative 1 and a positive 2 sine squared x. So combining like terms on the top, the 1's are going to subtract to give me 0, and I'm going to be left with 2 sine squared x. Likewise, on the bottom, when I combine my like terms, I get 1 minus 1, and then I'm left with 2 cos squared x. And that's pretty nice because after the 2's cancel, and I'm left with sine squared x over cos squared x. Boy, that's ugly. Holy cow. I could just write a little bit neater. Sine squared x over cos squared x. And I know that that's sine squared over cos squared is tangent. Things look good. So making some of those substitutions into your double angle formulas, that might help you out a little bit. Now let's solve some equations using our double angle formula. So if I'm solving this equation here, I know I got a lot of choices with cos 2 theta. I'm looking at that one though for sine. Because what I'm thinking now is, if I can use the sine substitution, I should probably get a quadratic equation which I can solve. So instead of writing cos 2 theta, let's write 1 minus 2 sine squared theta. I'll bring down my plus 2. I'll bring down my sine theta. I'm noticing my angle is going to be in radian mode. I got to remember that if I need to go to my calculator. So it's a quadratic equation. Let's set it equal to 0 and factor it. Maybe what I'll do is I'll move everything over to the right side of the equation. So first I'll move my -2 sine squared over, so it becomes positive on the other side, plus a sine theta. 1 plus 2 is 3. Let's move it to the right side and get a -3. There we go. So that's the equation we want to solve. And let's play a little bit of factoring here. 2 sine squared theta, so I'm thinking it's probably going to be 2 sine theta, and then a 1 sine theta. And if I got to multiply to give me a 3, why don't we try like a 3 here? And oh, that's not going to work though, because 3 times 1 is 3. But when I multiply those two together, I get a 6. And then I multiply these and I get a 1. And I want to get a 1 sine theta in the middle, so I better not do that. Let's get rid of that, and let's get rid of those two, and let's see if swapping works. Let's see if I can put maybe a 1 here and a 3 here. There we go. This is going to give me a 3 sine theta if I multiply my insides, and a -2 sine theta if I multiply my outsides. So my factoring looks good. Alternatively, you could do the quadratic formula if you like. So now let's see if we can solve these equations. We'll set each factor equal to 0. And if I'm looking at my row, that should be equal 0, I'm sorry. There we go. If I look at this right side of the equation, if I subtract 3 from both sides and divide by 2, I'm going to get the sine of theta equals -3/2. And remember that the range for sine is between positive and -1. -3/2 is less than -1. So there is no solution here. If I go to my right side, if I add the 1 to both sides, I get sine of theta equals +1. And I got to think, well, where in from 0 to 2 pi does sine theta equal 1? I don't know, do you want to try it on the calculator? Let's try on the calculator. I am in radian mode. So let's go trig inverse sine of 1. And I get 1.57. Do you know that as a decimal or as a fraction in terms of pi? It's actually pi/2. And you might remember that sine is equal to 1 at 90 degrees or at pi/2. How am I doing sig figs? 1570? Looks good there. Cool. So that's just solving an equation after I make a double angle substitution. Let's try one more together. Now this is interesting because sine only has one substitution. So if I do my double angle for sine, I get 4, start that again. I get 4 times 2 sine x cos x equals -3. That doesn't really help me. That makes my life more challenging because now I have 2 trig functions and only 1 equation. So that's not going to be the way to go. So I'm going to do a little something here because that double angle is going to screw me up. So let's do this instead. Let's say this. Let's let theta equal 2x. So then I'm going to change this equation. Instead of 4 sine 2x, now it becomes 4 sine theta equals -3. And that's an equation I know how to solve. So if I divide both sides by 4, I get sine theta equals -3/4. Okay, that's going to tell me that theta is going to be in quadrant 3 and quadrant 4 because that's where sine is negative. So when I go to my calculator, what I like to do is when I do my inverse sine, I'm going to do the inverse sine of 3/4. I'm going to do the positive, the quadrant 1 angle, and then I'm going to move it to quadrant 3 and quadrant 4. I'm noticing that I'm in degrees up here, so when I go to my calculator, I better change my calculator to degrees. All right, so now let's go to do some trig. Let's do inverse sine of 3/4. it looks like we get about 48.6 degrees. Okay, so 3 sig figs is 48.6. So now, let's hold on a second. We got to talk about this a little bit. Because that's my quadrant 1 angle. Remember though, if I'm going to move it to quadrant 3, I got to do 180 plus that angle. So let's go to quadrant 3 and let's add 180 to that number. And I get 228.5 or 229. So if I go 3 significant figures, I get 229. And if I'm going to my quadrant 4, remember that's 360 minus the angle. And when I do that, if we go to 360 minus the 48.6, we're getting about 311. Okay. But I didn't forget, I made a substitution before. Remember, theta is equal to that value 2x. So since theta is equal to 2x, if I divide by 2, I get x equals theta over 2. So what I need to do is I need to take these two angles and divide them by 2. So my values for x then are going to be 229 over 2. If I divide 229 by 2, I could probably do that in my head, but I got a calculator. So let's divide it by 2. So I got to go control enter on that. 114.5. So to 3 significant figures, let's call that one 115. And the other then would be 311 over 2. So if I do 311, if you ever want to do a decimal point somewhere in your calculator, that's going to tell the calculator to give you the decimal value as well. So I'm going to get 156 for that. And those two angles fall in my interval from 0 to 180. So those answers look good. So that's a strategy that you might want to use when you're solving for a double angle using sine. If you're solving a double angle using cosine, though, you can just make the appropriate substitution.